Welcome to a new test and teardown video. This time it's another one of those fantastic Hameg plug-in modules for the 8000 series mainframe. So here's a mainframe, and this plug-in module is called HM8030-4. So this is the fourth generation of this module. It's the function generator, and it's microcontroller controlled, or it's handling everything in software. Look at that. So there's an ADC51 microcontroller, and I think it's doing more or less everything. I'm just trying to find the DA converter and all that kind of stuff, but that is definitely what it's doing, right? And we got some really sexy details here. So the frequency adjustment is done with a potentiometer and a gearbox. Look at that. With a little belt and all that. That is very, very neat, because they wanted to have a good, nice ratio. And also a potentiometer with ratio and all that is just expensive and difficult, and it is too big, and you don't want to to allocate too much board space. Can you imagine that? So this is a good way to do it. Yeah. What else can I say about this one? Of course, we got not only just a sine wave and triangle and square wave and all the different output amplitudes and stuff like that. We got DC offset you can enable or disable, and we got a sweeper, and that I think is also a software thing. And in the sweep mode, we can select the width, how much you want to sweep, and the speed of the sweep. And I think we've got a lot of different ranges for the frequencies. I think that is what we do here. I haven't tested this one yet because I had to open and inspect it first. We got a little bit of problems with two potentiometers. I think the shaft's broken, and it's this type where you stick in a little plastic thing into the, it looks a little bit like a trimmer to begin with, but when you stick in this shaft, it becomes a potentiometer where you can put in an external knob like this, right? Yeah, and two of them, they are broken, and of course they are missing, but this is a standard knob, so those are quite easy to get. And I pulled out one of them, that one down here, just to show this exact type. So there's a 4mm shaft, and there's this little holding clicky mechanism here, and it's, if I take a random trimmer, see, they go into this hole and then they click in. This one also got a little the one of the click here is broken, so I'll have to fix all this, but I really don't have any of these on stock, and now I have to wait a whole week because it's holidays. So I want to design this and 3D print this and get this module up and running. But before I waste any time on this, I think I'll just plug it in and see if it's alive, and then I will take it from there. I have already proven this mainframe here works, so we should already... Oh, it goes a little bit into flippity floppity mode. So the frequency setup here seems to be quite nice and stable. It looks analog, so I'm not using sweep. Let's give it some output, and yeah, let's just show the output here, and then I dial. Oh, difficult. Then I try and dial the frequency. See? This looks like noise in the potentiometer. So that means the frequency is done by a normal oscillator And then the processor is probably just handling those oscillators. And that is probably also why it can do sweep. Let's see. Okay, so we have sine wave. Okay, here we go. Square wave. And then you push one more and then it goes silent. So sine wave, triangle, square wave. Okay. There's a little bit of noise in that little selector knob there. So when I push this, sometimes it's just skip. That seems to be gone now. This is typical when I need to demo something. Well. Yeah, it seems to still do that. Let's see if the sweeper is working. Okay, sweeper is definitely working. So this is the width, a little bit. Oh, a lot. All right. So I think I really want to try and repair this module since it really works. Cool. Let's dig into that. Here's another little important information and why you shouldn't underestimate any kind of challenge. I am so lucky that I got 2 different types of these, and this way I can reverse engineer it. See, if you see the end here, this is how the little knob goes on, because this fits here, right? And here there's a mate. There's a little matching that matches this side here, and this is where this little arrow is locked to that one. All right, so now it makes sense. It's the same with this one. So there's a mark and this little pointer and the little pointer here, it's all aligned to that one. But because of those two here, the potentiometers, they are mounted up and down. And for those 2 potentiometers, you need the white type, where this end here is here, and then the flat is here, right? And the black type goes here, because the potentiometer is sitting on the other way. It's rotated. I don't know if we can anyhow show that. Yeah, see? They're lying flat. So that means we got the end stops in the potentiometers, and that means we need the black ones for those. And see, the difference here is, see, now it makes perfect sense to have 2 different types. They're doing different things. So those 2 are black and those 2 are white. So this is important, and I didn't figure this out before today. I actually prefer the round ones and the other type of knobs where you just have a little screw up here and then you align the knobs. I mean, this is way too difficult to figure out, but and since I need the knobs anyway, I think I'll go and look at my knobs collection first before I proceed here. So of course I could 3D print those parts, and if we compare the 3D printed part with the original part, we can of course see that the outside is not as smooth as the original. It's a little bit in layers, but after all it really went perfectly fine. I was able to print them without any kind of support. I only needed to smooth them a little bit with a cutter. But as you can see here, the measurements and everything looks very much like the same. So I'm quite happy about the results here. If we try and see how well it fits, of course, due to the layers, it grips a little bit into the hole. So I had to adjust a little bit on the hole. I just took a little knife and just made it nice and fine inside the hole. You can see here it grabs real hard. So they fit perfectly in. Now that I adjusted the holes a little bit, and the little clicking mechanism at the end, it really fits perfectly fine into the potentiometer. See, I can pull and then click, it goes out. You can see here the little clicking part, and now I of course know the flat side is up. That is the line indicator, and then I just push and hold and then click, and it's nice and fine in. And I just made a tiny little slip so there's room for the rotation and all that. So the gray one is very important. Those two knobs, they're supposed to be gray, and the two knobs here at the top, they're supposed to be blue. That is how it is original for this particular version and model of this unit. And of course the potentiometer knob click here fits perfectly fine. So now this unit is done and working perfectly fine. We can now talk a little bit about the design of this fantastic unit. I want to start with the front panel. I don't know if it's super easy to see, but we got an IC right there and we got another one right here. And there's a flat cable going to the entire front panel. Just those wires. Look at that. And it handles the display, and those two switches, and I believe also those three LEDs, right? And if we look at the schematic, we can see how smart they have been. They're using two latching ICs, so there's a serial input, and then you latch the output to the LEDs. And to the switches, they're also latched outputs. And then they are merged together with three diodes. And then there is only one return signal to the microcontroller. And then it will investigate this signal and hold one of those test signals high at a time. And then this way the software knows which one of the buttons you're pressing. So this is a multiplexed switches as well. And then the IC for the multiplexed 7 segments, that is a very interesting IC. It's got, of course, serial input, but it's also handling the multiplexing of the displays at the same time using a little local oscillator. In the manual, you find a few different schematic snips of the main board, but there is no full schematic of the main board. So the CPU, or the microcontroller, with the little latch in here for the microcontroller's data to the EEPROM. The EEPROM is hidden, I don't know, yeah, here. From this angle we can just barely see the EEPROM. It is version 1.2 in this one. But there's definitely no access for that EEPROM. And most of all this, the digital sections here with half of that is also not in the schematic. So that is, for whatever reason, a little secret they try to keep. So you can imagine if you want to upgrade the software or something like that, well, good luck. You need to unscrew these and you need to pull the entire chassis apart. Maybe you can crack out this board here. And then maybe you will get access to the EEPROM. I think I've already said this before. This entire circuit board here is analog, obviously, and all the oscillators and everything like that is done analog. The way that the reason why this one got such an accurate readout is because there's a frequency counter in this one using a crystal, and it's counting the frequencies, whatever it is, and then just displaying whatever that is. So it doesn't matter, the oscillators and frequencies and the whole setup here don't need to be accurate. That is really, really smart, because the readout is accurate. I love that idea. So I can show the page with all the analog stuff. It's done using current generators and comparators and op amps, and this way it generates sine waves and triangle and all that kind of stuff. And the last page of the schematics, that will be the output amplifier, and it's a global feedback amplifier, and that is also why it has a very good and flat response from 0.5 hertz to, I think it's 3 megahertz or something like that. This one is doing. So it's really good design, and it's also stable for load and all that. Oh, there's just one little thing I really need you to see that is not good. So let's look here at the back. See the distance? It's like a 0.5 millimeter distance from tracks to chassis here. And it's so easy to fix. Why didn't they fix that? It is perfectly fine fixed here, so they know it. Oh, here it's almost a millimeter, but not so good. But then there's another one, even dumber. The screws here from the side. This one digs its way into that trimmer. It even damaged the trimmer. I am not happy about that. It would have been so easy, I don't know, to cut the tip of this screw or something like that. Not so good, huh? Yeah, you can see my 3D printed shafts. I kind of like that. Anyway, I think that is more or less all I wanted to show you of this fantastic function generator. I will get the new knobs in a few days, so it will be perfectly fine.